Hey everybody, welcome back to Everything's a Project. It's been a while, we'll chit chat later, but got the CNC machine going after all these years, and one of the things that came up is that it loves to throw chips around, so I'm making a hastily hokey frame that will hold shower curtains. So what I'm going to do today is I'm going to make a bracket that locates here and then has a support for this bracket, and that's the only intrusion of the path of the shower curtains. This should be a good demonstration of the CNC machine, because we have to machine a relief arc and 2 bolt holes, and so I'll show you how quick and easy it is to program it. It's conversational, and this machine uses a air for the drawbar and the misting coolant, so you might hear the compressor come on, so just a caveat with that. So I measured the diameter of this cylinder that we're going to clearance. That's 4 inch. Then the bolt pattern, easiest way to do a bolt pattern is measure the outside to outside. Oops, I don't have my phone. So it's 4.5 inch. And then subtract 1 diameter of the head, and that'll give you center to center. Oh, I goofed up. I need my phone. I have it on the charger. Okay, so it's 450 thou. So it's 4.5. So I mean, the easy math would be make it 4 inch, but it's 50 thousandths less. I'd get confused. I'm not a mathematician. Anyway, it's probably 3 inch 950. The other thing is the shop keeps getting a lot tighter. I have gotten rid of some stuff, but there's almost nowhere to put the camera mount. So I may bump into it. Let's see. I always use the calculator because it's safer for me. Like on the lathe, I always put in my target number, and then I put in my measurement, and then it tells me, you know, I don't have to keep track of it. I can watch it on the keep track of it on the phone. So 4 inch 50 thou. See, I went the wrong direction. I could have wrote it down. I had markers and stuff. Check this one more time. Yeah. Okay. So then what I did earlier, instead of taking this apart now, I have samples of all different bolts. So I went to my samples and found the head, the bolt that was 450 thou, and that ends up being a 5/16 18. So we need to know that because we're going to put the holes in here, and those will just be through holes. And I don't have the chart here, but I'll set that up after. Okay, so we're going to use this end mill roughing end mill to do our pocket. Hopefully this cuts pretty well. So I have it mounted securely in the vise and 1 toe clamp, but it does have some resonance. We'll see. Okay, I'm going to pull out the tool that's in there. Oops. Got to put the quill all the way up. So that's that guy. Okay. So the sun's coming in. It's early on Saturday morning. Okay, so now I'm going to switch the view so you can see the screen. Hang on. Zoom in a little bit. Oops. Okay, so this, I didn't introduce the machine. It's an Acra. It's a big Acra from 2006, I think it is. 10 by 54 inch table. You won't be able to see it, but it has a double set of dovetails for the saddle. So there's 3 gibs in Y. So it's kind of heavy duty, so it can handle the overhang and the back and forth. And that's what slowed me down with the repair, is getting the gibs dialed in. And the machine's actually now 0. There's no backlash. I had the screws repacked. It uses ball screws. So 0 backlash, and only a tenth or two in movement on the from the gibs. So it's tighter than it's ever been. Got rid of most of the oil leaks. It's got a little bit of a leak, but not like before. Before, what happened was some passages got plugged, and this isn't a metered oiling system, so other areas got overflowed, and then it was just pouring out. Now it just has a little leak. You know, the oiler go on occasionally, but not like it used to. Okay, so this uses Accurite MillPwr. This is the previous generation, usually called M2. The current one is G2. And nice thing about G2 is that it has more memory, and it has multiple datums, which I found was real nice where I used to work. That way you could have this vise set up as, say, datums 0 through 10. You could have another vise with other datums. This one only has a single datum. But anyways, it's pretty easy to program. So, first thing you do is go into program mode. Actually, first thing I should have done was pick a center. So this, it doesn't get indicated in or anything. I'll just arbitrarily pick a center. Should have left that little cutter in there, it would have been easier. So it's 2.5 inch. So that's good. That's good where it's at, because I need 5 inch is the total width of the plate. Yeah. So the first thing we're going to do is we're going to set our datum. I'm going to throw that tool back in there. I know you can't really see this, but I put that small cutter back in just so I got a visual reference. If you were doing something else, you could use an edge finder and then indicate it in, but this doesn't need that. So anyways, I lined up the back of the the part and then an arbitrary center for their work. So I'm just using a piece of scrap material. Okay, back to this. So now we're in the datum section. We're going to make X0, Y0 our datum, and then use it. After all your entries, you do use. Once we get into putting in our tools, then we'll set the Z datum. Okay, so 0, 0. So now we're going to use a tool. So first thing cancel. We go into program mode. So real quick, so this is nice if you're going to do just real quickie stuff that doesn't actually need a named program. So like facing, a lot of times I'll just come in here, tell it what tool I'm using, say okay, then go to the rectangle shape, then it has the face option right there. And then I just put the cutter at the one corner and the cutter at the other corner, and then it'll just fill in the blanks. Okay. So we're going into actual program. So there's no program yet. Then the first thing is to select the tool. And what size is this? 5/8 maybe? Yeah. So 5/8 roughing end mill. So you put in the diameter, and now it's going to do all the math off of that. And then tool type, it doesn't need to know the tool type. You just put it in for yourself. So if you run this program again, you know that it was an end mill, not a drill or something like that. And enter that. Spindle, it doesn't control the spindle. You turn it on and off. But again, you want to select forward or reverse because it's going to give you a prompt when it wants to run, and that's just a safe reminder to tell you to turn on the spindle. And then if you had a specific speed you wanted to run, you can type it in there. That way you can visually see what to set the head to. On other configurations of this, it'll control the head. On this machine it does not. And then you're going to tell it your safe position. So I always go to my 0, 0 point and then 250 thou above my touch off. And then you always want to say yes to the tool change, because then that'll pause the program. It'll finish the cut and then it'll stop, and then you would switch to a different tool. If you're using the same tool for all kinds of stuff, then you don't have to do the tool change. But it's safe to do that. That way it doesn't now run this tool in when you want to drill a hole or something. Okay, so use that tool. And then we're going to do a circle. And we can do a pocket, which is essentially, it'll come down in the 0 point and then just work its way out until it makes the diameter of the pocket. I think we're going to do a ring, and then the ring, that way it'll just cut. Actually, you know what I'm going to do? Okay, so it's a 4-inch diameter, and that would mean that I'm going to cut a lot of air if I did this way. So I'm not going to do that. So what I'm going to do is I'm going to do an arc. So it's going to follow a path that I designate, and that'll be the arc. So we're going to go from -x, which is the left of the tool, and we need a 4-inch diameter. So we're going to go 2 plus some clearance. So 2-inch, 0.050 thou. And that'll go over to there. Then we're going to do Y, and we're going to go positive. You could use 0, but that'll put you right on the part. We'll start a little bit off of the part, and then that'll be 100 thou. So 0.1. And then, so that's the beginning, and then we're going to do the same thing to the opposite side. Now it's a positive number, and it's still ending at the same Y position, which is 0.1, 100 thou. And then begin, I always start 10 thou above, so a positive number is above your touch off. And the end is a little bit below the thickness of the material. So that's 260 thou. So we'll go 300 thou, 0.3, and then that has to be negative because that's going below your touch off point. The feed is how fast the quill is going to go down. The radius. So the radius is half of the diameter. So that was a 4-inch. And it's not gonna, it should, if I put in 4-inch, it should conflict. No, it was gonna squeeze it. But we want to go the 4-inch 100 because we added 50 thou on both sides. Oops. Go 4. Okay, so there it didn't like that at all. Oops. And I guess it's only going to warn me once. Okay. And then we can tell it to do from clockwise or counterclockwise. And since we're working inside of the material, it seems to cut best going counterclockwise. When you're on the outside of the material, it seems to work best going clockwise. So we're going to go counterclockwise, which it's selected for us. Okay, now the tool offset. So if you do center, it's going to put the center of the tool on your path. So you'll end up over usually. I can't recall if it completely does the math or not, but what I do is I always run inside of my path. And then it calculates in the tool and seems to work fine that way. So so we're going counterclockwise. So you want the tool to the left of the path. And so that's right here. Or you can do inside. Inside is easier. On circular shapes, it gives you inside and outside. On rectangular shapes or straight lines, it's either left or right. Inside is the easy way to go. Okay, then feed, that's how fast the cutter is going to move. So I go to 20-inch, and then you can go as slow as 0% or up to 50% over with these once the program's running. So you have a lot of control. So we're going to use that program. Okay, so there's our arch. Looks a little shallow, but we'll see. I don't need a lot. I want a good amount of this material, to hang out, because I'm going to weld a 1-inch square tube on the front of it. Okay, so then we also need some holes. So we're going to go change the tool, and I forgot what it's going to be. I'll look at what the clearance size is, but essentially it's 5/16 with the clearance. So I'll put in 312 for now. It doesn't need to know. On this, it's not going to calculate the diameter of the tool into the function because it's just going to go to a point. And that's the drill. I'm going to skip that because you already saw that stuff. I always say yes to changing the tool. Use that. Now I'll go to position and we are going to go in your X is going to be negative because we're going to go to the left side first, and that will be 4*50, and that's divided by 2, so it's equal, so it should be 2025. So 2.025, that's in the X direction. And then what we're going to do is we're going to guess on this because we'll have the graphic display and that'll tell us the relationship to the arc. So on some of this you don't have to get bogged down with a lot of the measuring and stuff. So we know we're going to have that arc, and our Y is essentially the back of the material, and so we'll come in, take a guess, probably we'll do is this 3" wide? 2.5. So I want to do half of that. So 1.25 inches, or yeah, 1.25 inches. So 1.25, but it's towards the operator of Y, so that's a negative number. Okay, and then the begin and depth are the same because we're drilling all the way through. You can set up to drill, have it drill automatically, but if you do through, actually I need to do that up here. So on holes like this, having the machine do it is kind of tedious. So what you do is you, instead of giving it a depth, you say through. And what that's going to do is that's not going to drive the Z-axis when you get to that point. And there's a knob here in the front, it's probably out of view, that you can disengage the Y, and now you can manually, or sorry, Z, and then you can manually do it. And so on stuff like this, it's much faster. So there's a lot of flexibility with these things. So I don't need to tell it to do any other drilling functions. You can, here you would tell it how many pecks per depth of cut, how much feed, and then how many retracts you want. So if it was deeper stuff, how many dwells when it's up, how long to stay up, so like the mister can cool off the tip if that's the case and blow off the chips, or you could grab with pliers, you can pull off any bird nest or anything like that. And then if you were doing a blind hole, then you could have it dwell in the bottom of the pocket. Okay, so then we're going to use that, and that's not looking bad. So you can see graphically it's telling me where we're at. I will say I think I'm going to move it in a little bit. So instead of going 1.25 inches, let's try 750 negative and use that. Okay, so you see we got tighter and we're kind of in the pocket of that shape. And I believe I like that. What we're going to run into is if I don't get this right, it's not going to fit, then I'm going to have to put it back on the mill, and it will be a problem with putting it back on, setting it up all again. Okay, so I'm going to just, I'm out of view, I know, but I'm spot checking the relationship between the two. what I'm going to do is I'm going to tighten up even more, because I believe that's the safer route. So we'll go 1/2 inch negative. Yeah, I think I like that. Let's see. Let's see if haste makes waste. Okay, so now we're gonna make, that's one hole, we're gonna make the other one, and it's symmetrical. I like to do as much stuff as I can off of center when things are symmetrical. So then when you program your second move, all you do is turn it to a positive number and it's done. So now we are going to load the tool. Again, out of view, I have the R8 collet rack. Okay, we're going to get rid of this tool. We're loading the 5/8 roughing end mill. And one thing you can do too, like when I programmed extra 50 thou for the arc, you could actually lie to the machine and tell it that you're using like a 600 thou diameter cutter, and it will push the cutter outboard to achieve the size that you want. So that can be handy when you're setting up for like a roughing and finishing. It does offer finishing passes, but it's designated for the same cutter. So if you're going to change cutters in the middle of it all, then it's good to just trick it. Okay, so I'm out of view right now. I'm going to finish this and I'll reposition the camera. So I loaded the tool and now I'm touching the tool to the surface of the part, which I'm comfortable with doing. I'm not mashing it. It's not carbide, so I don't have to worry about hurting the tool. So then we go back into DRO. That's where the datum is. Go to the datum. Now set my Z datum and use that. So you can see I moved the table so I can get the cutter on top of the workpiece. Okay, so now that's all set. What I'm going to do is I'm setting the table. So the table is still hand cranked. Actually, I didn't give you a good view of the machine, but this has all conventional manual controls also. So you can run this machine manual or with the CNC assist. What I just thought of, and it might just be senile decay, did I tell us to do a couple passes? Oops, I don't want to do that. Okay, one thing that I forgot to show you is the way I programmed it, it would do all the cuts in one pass. We don't want to do that. So my bad, I'm a little rusty on this. So I just got going last week and I did a couple little projects. But what you need to do is you need to tell it your first depth of cut. So we'll go 30 thousandths to be nice and conservative, because this is just kind of marginal on the setup. So change that to 30 thou negative and use that. Okay, now you want it to do the same thing multiple times. So you do repeat. And the repeat, you tell it what toolpath to use. So it's only one line of code, which is number 2. So it's going to do that same path as many times as you tell it. And what you're going to change each time is you're going to change the depth of cut. So you're going to do that another 30 thousandths, 0.03 in the negative. And you can use this feature to make, because this doesn't have like a, I don't know what you would call it. Say you wanted to make a bowl. This is kind of how you would make the bowl. You would adjust it in Z and X and Y per pass. It doesn't have all the fancy stuff. Now you can use CAM programs and then load them into the machine, but I don't want to get into that. Okay, so we need to repeat that how many more times? Essentially, we're going 300,000, so it's 30 passes, but we have one pass we're already doing in the original tool path, so we need to do it 9 more times. So this is going to be slow going, but hopefully nice and safe. And use that. Okay, so now we've got everything going. Let's change your view. Hang on. Let's see if I can back out a little bit. Okay, hopefully that works. So now, hang on, I gotta squeeze past the. I'm going to lower the table 100 thousandths so that I can do a dry run. Without touching the workpiece. So we'll get the spindle going. So that's 1,000 RPM. I have my little squirter here. I made a system. It's in the back. It's a tank from a house water filtration system. Then I have it all plumbed. And I got it where I have a switch here on and off to juice it up. Okay, so the first thing you do when you program this is the machine does not know what tool's in there at the moment. So you introduce the tool. So I'm on that line of code and turn down the feed on everything just in case you make a mistake. So I say yes, or go. This is the go button, and that's the stop button. Okay, so it's telling me there's no current tool. It's about ready to change that. Tool goes up, comes down, goes to the 0 point, and it stops at the 250 thou above the workpiece. Okay, so we just introduced the tool. So now the the machine is saying that it knows that there's the 5/8 cutter in there. So now we enter past that, and it's going to go into the tool path. So now it's, because I selected forward when I set up the tool, it's now prompting me to turn the quill on, and it is on. So now we're going to go say go again, and now it's going to do its thing. I do have a lanyard I could have had in my hand, but we'll go here. So okay, so that is extremely shallow of a cut. See, now it's going to do it again. It's going to drop another 30 thou. We're still above the workpiece. And I was just going to change it so it engages more, but I think I'm going to stick with it because I have other things to clear. I don't know if it's in view. Let me get the viewfinder here. Yeah, so the power drawbar controls are right there. So I think it'll be best to be as far off as we can. So, having said that, let's raise this up back to our original touch off. So I'm raising the table back up the 100th thou. Okay. Now we need to get the important stuff out of the way because this baby throws chips. That's why we're adding the curtains. Okay, I got a little table over here that's getting full of chips. Let me grab my safety glasses. Hold on there, Betty. Oh. Oh, while I'm behind the camera, I'm going to go see what drill bit, grab the drill bit for the bolt holes. So 5/16 18 clearance is a P drill for tight clearance. But I prefer that if possible. Okay, you ready? Fire it up. So the tool is already introduced, so we don't need to introduce it again. So we can go right into cutting. Bring the feed down. Bring it way down just so we can have control of what's going on. Seems pretty good. I'm speeding up the rate, the feed rate. So I'm at 75% of what I had said. I'm backing off the coolant because I don't think it needs as much. So I'm going to just feel it feels good, not a lot of vibration. My workpiece. Looks like I did pretty good with the RPM for the tool. I haven't been fooling a lot with speeds and feeds. Nice C6 chips, and they're not discolored. I'm definitely not pushing it, but we can get into it heavier and stuff. Oh, and then if you go to CRO and change to absolute, it'll tell you what actual depth you're at for the cut. That's handy. We'll go faster. So now we're 115% of my original feed rate. I told it 20, I think it's inches per minute, now it's 23. So we were at 180 thou depth of cut. We'll go so I went to maximum on the feed and I've given it some more RPM. And we're almost broken through. You can hear the remaining material fluttering. Don't mind me, I hastily stashed an extra piece of conduit and it just fell. Didn't hurt anything. Okay, so there it is, there are 3 So now it goes to that point and it stops. You have to shut off the quill, and it's now prompting us to change the tool. And I haven't explored it enough. I stopped the program, but I think I can eventually get where it pauses the program. I can change out the tooling, rechange the Z, but I'm not sure yet if I can do that. So now what I'm going to do is just manually, or using the power, but arbitrarily, move the tool away from the workpiece. Make sure the quill is retracted. Change out the tool, so now I need the drill chuck. And if I was using a 5/16 drill, then I could just use a collet too if I wanted. But we'll load the drill. And there's a brake hidden in here behind all this stuff, so I just hold the brake, tighten it up, lower the table. I don't know if you saw it, but it says a great heavy duty handle. Get my exercise. I don't want to get fat from using the CNC. Okay, so I just changed the tool, lowered the table. Actually, bring it up a little bit. Now I'm over the workpiece again. So now I'm going to touch the drill to the surface of the material, go back into the datum, and change the Z datum, and use that. Okay, now that's a good habit, but I'm not going to have the machine do the drilling. So now, let's see how this wants to run. Should be able to disengage. So this disengages the quill feed. So now it's like a regular mill. So now I can do it manually. I believe it will work properly. Sometimes it still wants to drive. Let's make sure. Okay, so back into the program. And then set the, okay, it's not going to like that. It wants to, I got to set the tool first because it's going to do its little thing, setting it a 1/4 inch above the workpiece. Okay, so we're introducing the drill now. So I like to always have the tool spinning in case there is contact. It helps to keep from breaking the tool. And on this kind of quickie stuff from scrap, it doesn't matter if I mar it up. So anyways, here we go. Let's introduce the tool. So right now it thinks, it remembers there was the 5/8 cutter in there. It wants to be, it gave me a Z-axis fault because it doesn't want the quill fully retracted when it does this kind of stuff. So there we go. And now it's introduced. So now it says it's at 312. Okay, so now we'll go to the program. Okay, so now it says through hole. So now we disengage the quill, or my squirter some. Let's see how the RPM is. The RPM is probably high, 1,000. I don't need a center drill for this type of stuff. Huh. Okay, well that's interesting. This bad drill. Usually. Maybe between deflection. Doesn't want to give me a good good start. Hang on there. Drill looks okay. Gonna bust my balls about everything, I guess. So, actually got center drill over here, so we'll give it a center drill. Again, this isn't a precision thing, so I am putting the center drill in the drill chuck, but not this one because it's too big for it. Should have center drills over here. No, all my center drills are dispersed. Hang on. Yeah, normally I just blow right through it with split point screw machine length drill, but there's probably some deflection and not liking either, so it's not getting a good bite. Okay, so it's still in position. I can fire up the quill independently, get that going, make it nice and deep. I love these brushes. Just the cheap brushes are the best for clearing chips. You do not want to be blowing your chips. They get into everywhere that they shouldn't be. Okay, fire it back up. Bring the RPM down. Give it some juice. Let's see how it likes that. And that's a little fast. You can tell by the noise. That's all she needed. There we go. Little stubborn guy. And I always try to conserve the coolant mist. That's why I have the handy. Can you see? Yeah. Right here, nice and handy. Because the only thing my neighbors can hear is the air compressor. And without this machine, I almost never had to use the air compressor. Plus, if they can hear it, then I can hear it. Okay, so now we're still in the program mode. So I just hit go again. And now it goes to the next position. Okay, now fire up the center drill, bring up the RPM for that guy, give it a little juice. Now if I was having this do control the drilling, I wouldn't be able to go back and forth on these tools like this because it would throw off my Z depth. So you got to keep that in mind. This must not have a good tip because I went shallower on the center drill this time and it's fighting. Hey, guess what the name of this channel is? Everything's a Project. Yeah, so this drill is hot. So that guy's getting replaced. And it works out nice because a while back I ran across the shop closing up and they sold as a lot full packets of letter drills. So I kept some, but I also sold off sets on eBay. So I'm all done doing that because now I just have for me. Because I suck at sharpening drills. And in the realm of everything, just replacing them is easier. Okay. So, we're all done with that. We're done with the program. Stop that bad boy. So I think you can see, so there's a light arch here to clearance and then the bolt holes. So hopefully that fits. We'll know shortly. I do have to cut it down. So one thing I'm going to do, another programming thing, and this will be a good example of the light programming. So what I'm going to do is we're going to change out the tool again. Get rid of the drill chuck. We're going to put in this small end mill that I just happen to have here. Okay, so our 0Y is the back edge of the workpiece. So we're going to do a quick program. So in this case, the diameter of the tool does not matter. I'm going to do a line, and I'm going to go from my X point stand corrected. I am going to tell it what tool. It's a 1/4 inch end mill, 0.25. Enter. Re-engage the quill. Come down, tell it we're going to run it forward. 0, 0, 0.25 again. Yes. So if I don't want to introduce the tool to the machine, then I could deduct my half of my diameter when I tell it where I want that line to be. And what I'm going to do is I'm putting a line, and that'll be where I put the saw when I cut off the excess material. So what do I want to do? I want to go into, use that, DRO. Oh, okay, that's how it works. That's nice. I just did that. Now this is how I introduce the second tool. Okay, I like that. Okay, so now we need to introduce this tool. Oh. Okay. That's not it. Okay, anyways, we won't do that. So we'll go back to my original idea. I just want to quick program the line. So I'm nothing large. So I'm not going in program mode. It's still in DRO, but essentially I'm using it to computer, get to the point, and then feed. So the plate width is 5 inches. So .250. Oops, that didn't work. Okay, stop being an idiot. 2.5, but we want to come in half of the cutter, so it should be 7/8. 2.5 minus 1.25, 2, oh no, 2 3/8. Oh yeah, okay. Don't listen to my head math. 375, negative position. We want to start a little further back, so we're going to 0.25 in Y. That's positive when it's away from the operator on the of your 0 point. And then you're going to go same X, because it's a straight line, and then this is a 2.5 inch wide, I think I said. Yep. So we'll go 2.75, and now it's negative because it's coming towards the operator. Begin 0.01, and then end . I'm actually going to tell it through because I'm going to set the depth. It's taking longer than I thought. Let's see, left. So I would want the cutter . And it's doing more math than I want. Okay, never mind. Stop this. I'll show you one other way we can do it. Okay, so we still have the DRO. Let's go over to that point, 2 inch 375. And I think I could type in and it would go there automatically also. 675. Okay. Actually, what I want to do, I want to go on the other side so I'm not marking up the good part. So now we want to go 2.5 to 625. That would even be better. Okay. So now touch that. Now I can lock the quill. There is a quill lock. So I lock that. Set the table to 0. Lower the table for when I start it up. Forward. Put a little more RPM. Move the table. I want to slow down the feed. So we'll try 50% of what I just did. Not too shabby. We're not going to do a lot. So we'll do a 20 thousandths cut. Doesn't need a lot, but I don't want to, well, you know what? We'll do a 10 thousandths cut. This material might not be too uniform. So now, just come across. That's a little fast. Lucky I did 10 thou. Okay. So